Direct and partial variation. Here are a set of questions which will help you to understand direct and partial variation. These are basically true or false questions, and if they are wrong, you need to write correct statement. The idea of giving these questions is to make this concept absolutely clear. What is direct variation, what is partial variation, and introduce to you the related terms like rate, slope, change, variation, dependence, independence, variables, relations. There's so many terms which will be introduced in this section. So go carefully and don't just think these are true and false, right? Writing T or F there will not serve the purpose. So read the statement carefully, answer it. Once you have answered, then watch my video further for explanation and suggestions. Okay? Here is question number 1. Direct variation occurs when the dependent variable and the independent variable both increase. Well, let's really sketch something which relates to direct variation, correct? Let's say a simple graph like this. Here, this is x, the independent variable along horizontal axis, and y is my dependent variable along vertical axis. That's the origin. And this line indicates that it is a direct variation. Direct variation will have characteristics like these. Always make a note of these. First, it can be represented by a line y equals to kx, or we can say y equals to mx, where m is the slope of the line. When we use y equals to kx, we are talking about a constant. And what I really mean by that constant is, let me write in a different way. If I divide y by x, I get that constant. So let me write this as the second condition. Y divided by x is always a constant. This is kind of very important. And sometimes we call this constant as kind of a rate. Right? In this equation, y equals to mx, m is the slope, right? M is the slope here. So we call this as where m is slope. Let me write here where m is slope, right? K is constant, rate, okay? So these are related terms which will help you to understand what a direct variation is. Another important thing is to note that direct variation doesn't really mean that your line will be in the first quadrant going from 0 onwards. Correct? Any other line but going through origin. For example, this line going through origin, it may extend on that side also in quadrant 3. Or a line which is coming from here and going. This is also a direct variation, right? The only thing here is that here the equation of this will be y equals to, let us say, minus k. K is negative here, okay, but that's fine. K can have any real value, where k belongs to set of real numbers. K have any real value, okay, but k is not equal to 0 and k is not equal to 1. So these are the two restrictions on the constant, okay? Because why are these restrictions there? K is equal to 0, that means the line was going to be horizontal, correct? So it is not varying at all. When we say direct variation, then x value and y value need to change. If they are not changing, then it's not a variation, right? So remember that, correct? So this could be a line which maybe like minus 3x, for example, right? It's negative slope, but k here is negative. K is negative, and that is fine. But k cannot be 0 or 1, correct? If k is 0, then how will the graph look like? Let me get to those conditions also. I'll show you here. If k is 0, then y equals to 0, right? Then we have a line here, correct? Now, in this line, you can see that there is no variation along y-axis, correct? So there is no relation between dependent and independent variable. In fact, the dependent variable is constant and it is 0, correct? So here the equation is y equals to 0, right? Or if I draw a vertical line or a horizontal line here, right? Here k is 1, k equals to 1. We say y equals to, let us say, 5. But there is no variation in y. So this is not a direct variation. Well, it is not going through origin also. So you could say it's not direct variation otherwise. Well, if I draw a vertical line here, then this vertical line goes through origin, but there is no direct variation in this line. So those are the exceptions, right? When we write it, k cannot be 0, k cannot be 1. And of course, for a vertical line here, we cannot write an equation in y equals to kx form. What is the equation of a vertical line? Can you tell me that? That is a question for you. Here, as a note, the equation of a vertical line will be x equals to 0, right? Not y equals to. So that is not really covered by y equals to kx equation, and that is why it is not in our restriction here. So the important restriction here is that k, the constant, or the slope of the line which goes through origin, should not be 0 or 1 for it being a direct variation. Therefore, direct variation occurs when the dependent variable and the independent variable both increase. Is a very limited kind of a definition. It is, I should say, wrong, because they even don't say increase by what factor. Now, to give you an example here, I can say, well, see this. Both are increasing, right? And they may go through origin like this. Do you see that? Both are increasing. X's value is also increasing. Y. But is it a direct variation? No, it is not direct. It is not direct, right? Why? Because the rate of increase is not constant. It is not a straight line, correct? This ratio y equals to kx is not maintained here. It does not represent y equals to mx. That is why. But these are examples of direct variation, right? This is direct and this is direct. But these are not direct. That is what you need to understand. And this, of course, statement is false for us. I hope you understand a lot from here, and that is how we are going to go through this section of understanding direct and partial variation. Thank you.